A practical solar home will have a large surface area devoted to harvesting the sun's energy. But solar heat may only be collected when there is sun energy to collect. The heat energy must also be stored to have lasting value. Differential controllers are used to automate the heat collection and heat storage process, and temperature probes are used to control the controller. Calibrated temperature probes are often used where accurate temperature readings are needed because they respond with voltage directly proportional to temperature. Thermistors may also be used to control differential controllers. They respond to temperature by changing their resistance. For example, a 10K NTC thermistor has a resistance of 10K at room temperature and drops to 2K at 140 degrees Fahrenheit. Although this resistance is nonlinear with respect to temperature, the change in resistance is sufficient to drive a differential controller and also approximate temperature. A thermistor resistor voltage divider may be used to generate a voltage proportional to temperature. As the temperature increases, so does the voltage. A bar graph generator may then be used to generate a visual representation of temperature. This bar graph reads like a digital thermometer. The temperature that's indicated here is 80 degrees Fahrenheit. This differential controller uses two thermistors to sense a difference in temperature. It also uses a thermistor resistor voltage divider network to generate a bar graph display to approximate the temperature of both the collector and storage temperature. If we want to see how the resistance of a thermistor changes with temperature, we can simply bind the thermistor to a calibrated sensor and heat both probes uniformly. Calibrated sensor bonded to a thermistor, so the temperature of the junction where they both meet should be the same. On the right you can see the actual temperature of both probes. Right now it's 66.5 degrees. On the left you can see the resistance of the thermistor. Okay, so we're starting with 66.4 degrees. Now let's add a little heat. I have this heat gun here. We'll add some heat and watch what happens to the resistance of the thermistor. You can see the temperature is just starting to change. 66, 67, 73. Now look at the resistance already. Took the heat gun away. See, the resistance went way down. Now it's about 6.5 kiloohms. And the temperature is 92 degrees. Okay, we'll let that equalize a little bit so you can see. So it's probably just about 7K at 90 degrees Fahrenheit. Now let's raise the temperature a little more. Okay? All right, keep your eye on the resistance. See, right now it's 6K. The temperature is 103. Now it's about 4K. Temperature is 114. Jumps around a little bit, but as soon as we take the heat gun away, it should equalize. Alright, so the temperature is now 173 degrees, 175, and you can see the resistance is pretty low now. It's 1.35 K, and the temperature is 170. Okay, so the basic thing that you want to know from this is just that the resistance of the thermistor gets lower as the temperature gets higher. This is the differential controller here, and this is the bar graph indicator. Now, you won't know exactly what the temperature is, but you should be able to approximate it to within about 5 degrees or so. Now, we also have, I call this the pump over here. Now, I know it looks like the taillight of a car, but actually, for this demonstration, we'll think of this as the pump. So,
in order to turn the pump on, the collector temperature has to be higher than the storage temperature. You know that, right? Okay, but first thing I want to do, we'll toggle this switch down. We'll be looking at the storage temperature, and this is the storage probe right here. So I want to heat this storage probe up. Okay. Now you can see the temperature start to rise. That's 70. The minimum temperature needed to register on this barcode indicator is 70 degrees. Right now it's about 100, 120, 130, and the top bar is 140. Okay, so it has a range between 70 degrees and 140. And that should be fine for almost all solar hot water systems. Okay, so we've looked at this is the differential pot, by the way. We'll talk about that. What I did is I set the differential to a very sensitive setting. It's a very low differential, so the difference in temperature between the collector and the storage doesn't have to be very high in order to turn the pump on. Right now, the storage temperature is 70 degrees and the collector temperature is below 70. So I want to heat up the collector temperature to turn the pump on. Okay, 70, and 75, 80 degrees the pump comes on. So that's a differential of about 10 degrees, and then the pump stays on for a while, and then when it gets low enough, the pump should come off, and there it goes off. So the differential is around 5-10 degrees or so at the lowest differential. Alright, now if we increase the differential, let's turn it up about halfway. It should take more heat to turn the pump on. So let's heat the collector. Let's see how much hotter it has to get now. Right, we know the storage temperature is about 60, 70. Alright, so now the differential is 15 or 20 degrees higher than the collector temperature is 15 or 20 degrees hotter. And then it takes a little longer to turn off. And that's what we want. We want it when it's the differential off setting should be much closer to the storage tank temperature. Anyway, now the next thing we want to do is that lopsided? Oh goodness. Alright. Gee, I'm getting out of breath here. Okay. Anyway, okay, the next thing we want to do, we turn the differential all the way up, so it's going to take quite a bit of heat in order to turn the pump on. Let's see how hot it has to get. We're already up to, alright, so the temperature now is about 130 degrees, and the storage temperature was probably about 60 degrees, so I don't know, maybe 60 degrees for the differential to turn the pump on at the maximum setting. Now we wouldn't normally use that setting. That's a very high setting. That's very odd. Your setting, the most practical setting is going to be somewhere between these two extremes, okay? And that's all you have to do to adjust your differential controller with the bar graph indicator. Okay, well anyway, that's the basic idea. That's how it works. And thank you very much for your time.
If we set the differential too high, we'll collect less heat. But if we set the differential too low, the power consumed by the pump may be greater than the heat collected. A counterclockwise setting maximizes the heat harvest, and a clockwise setting maximizes the energy conservation.